Today we will be looking at quality control charts, which are a key element to statistical process control. Quality control charts are designed to detect statistical changes in quality over time. If we calculate a parameter such as sample mean over time, we have a chronological map that shows us exactly when and when not our process is in control. And as engineers, this is very helpful to us because our processes are often subject to nature, which means anything can happen. So the fact that we have a chronological map of our process means we can go and look exactly where it runs out of control and possibly track that down to an exact cause, such as a wiring malfunction or a loose valve or anything that could cause our process to run out of control at a certain time. And that we have that timestamp is helpful because we can go look at certain parts of our process. In this case, I made up an example of a machine that manufactures bolts that are supposed to be exactly 10 millimeters in width. I took 20 samples, got the mean for each one, and assigned each one to a day, which means we took 20 days worth of samples. To get the control, we just took the means of the sample mean, the mean of the sample means. And to get the upper and lower control limits, we added and subtracted 3 standard deviations from that value respectively. And this is basically all we need to plot a X-bar chart, and we will use sample means values on the y-axis and time values 1 through 20 days on the x-axis. Now that we've plotted, you can see that our process runs in control for the entirety of the 20-day period. We do have 3 points that jump considerably far below the control line, and we can always investigate those because we know exactly when they happened. And this is the benefit of control charts, is we can decide when or when not it is worth investigation. And it's often said that X-bar charts are histograms flipped on their side and vice versa. In this case, this histogram models the X-bar chart if it was flipped on its side. As we can see, there's a slight skew to the left, which means our process runs a little bit over 10 millimeters each time, which means we're producing bolts that are a little bit wider than we'd like, but as we can see, there's no outliers or major skew. So this supports the fact that our process is running in control, more or less. And if we go back to our chart, we can see that this is supported by the fact that we hang above the control line more often than not.